Welcome back. This is part 2 of the how to build a top-down shooter in Unreal Engine using C++. And I'm working on this as I go. I don't really know where I'm going to stop, what direction this is really going to take, and this is kind of where I'm at now with some guns to pick up, different types of guns, and just some enemies to shoot and test things out. So leave a comment below about what you'd like to see, maybe the direction you'd like to take this, and we'll go from there. By the end of this part, we'll have a character that faces the way it moves, as well as faces where we're clicking, and this is kind of the foundation for everything we'll need to move forward from here. I recorded ahead when I didn't have all this energy, so to get started, let's go to Tools and New C++ Class. And here, we're going to go to All Classes and look for PlayerController, because this has functionality we'll need to make use of. So we can select PlayerController, go to Next. We'll name it Simple PlayerController and put it in the Controllers folder. But first let's select private and then public to make sure we get that public directory there. And PlayerControllers. And let's create this. Once that's done, do reload all in Visual Studio. And we now have an empty PlayerController class to work with. Back in Unreal, let's head to the C++ public folder and make sure that we have our PlayerControllers folder here. Looks like everything is good. With this being made, we can now head into our world settings and change our PlayerController class to our Simple PlayerController. This will bind our Simple PlayerController to our player character whenever we start the game. This PlayerController has some additional functionality we can take advantage of to help understand where our mouse is. So we'll create a member function here that will return an F vector, and we'll call it getAimDirection. Then we can use a little screwdriver to create the definition in our CPP file. The functionality that's going to help us understand where our mouse is in the world is the dproject mouse position to world, which is a member function of the PlayerController. And if we look at how it works here a bit, we can see that it returns a boolean, true or false, for whether it was successful or not, as well as taking in two F vector references for world location and world direction. Given that this member function dproject mouse position to world is going to be the basis of this member function, I think it's best to change our F vector to a bool and match the return result of the member function we're going to be using. And then for now we can just return false. I'll grab this member function name dproject mouse position to world and paste it in to see what information we can learn from it in our IDE. So we see that it takes the F vector references for world location and world direction. So let's declare those so we can pass them in. We'll create an F vector, and personally I like to say position, so I'll create world position, and we'll paste that and make world direction, and these will be filled by the call to our dproject mouse position to world. So when we pass these in, it'll take those and set the values, and we'll be able to reference them later to see what values were set to them. To help us understand what we're getting back from this call, we can draw a debug point passing in the world position that it fills for us. The first argument wants the UWorld, so we can just pass getWorld, and then it wants the position, and we want to see what world position is. Next, it just wants a size, so we can just go with 1.5F for now, see what that looks like. And then a color, pass in any color you like. I'll go with yellow, sounds good. And persistent lines, yeah, for now. And that will wrap this up, and now we'll be able to see what world position is when we call this function. So let's head over to our simple character CPP file and find the member function where we are starting to shoot, and let's add a call to our new PlayerController member function getAimDirection. First we'll need to get the include from our PlayerController and place that at the top of our simple character file. Then we'll be able to reference our PlayerController and cast it to that specific simple PlayerController. So create a variable to hold our simple PlayerController reference. Name it whatever you would like. I'm going to name mine PlayerController, And we'll set this to cast with a type of a simple player controller, passing in get controller with a lowercase r. Oh, and don't forget to make it a pointer. Now, this will give us our controller as a simple player controller, allowing us to call our get aim direction member function from that. So if we type player controller with the pointer and then look for aim or get aim direction, it would help if get aim direction were public and available to outside classes. There we go. Now we have it. So now we have our get aim direction member function on our controller wired up to our start shoot. Let's live compile our changes and see if we can see our debug points when we use our click action. Okay, well, these debug points are horrendously small, so let's update that from 1.5f to maybe just say 15. Live compile again, and okay. These are actually more helpful now, and you can see that they're very close to the camera, as when we move our character, the dots move all over the place. So this is our world position that we're receiving back from the deproject mouse position to world member call. And while doing that, I noticed something. We don't see our mouse. So let's add a protected section to our simple player controller, and we can reference our simple character header file here to see what the begin play looks like here, copy paste that into our simple player controller, and now we have a begin play member function that will be called every time the player controller begins playing. So I'm going to move this up here, and we can use this to set the boolean for b show mouse cursor. This is a property of a player controller, and just setting this to true, we will now see our mouse in the game world. Much better. You can actually see what I'm doing now. And I might be having just a little too much fun clicking little squares onto the world. Now here's something interesting. If we detach from the player controller, we can actually see where all these little points are in the world. And you notice they're all in a very small space, right where the camera was. So now we have a pretty good idea of what our world position we're getting back is. Let's take a look at the world direction now and see what that looks like. For this, we can do a draw debug line, and similarly we can pass the get world, and the line start would be the world position, and the line end is going to be the world position plus the world direction, and we can multiply world direction by 1000 to better understand it. Then we can pass in a color, and we'll go with blue, and persistent again. With a live compile, we can play it again and now see what our world direction looks like. If we click, we notice that we do not see any line, but when we move, we can see that the world direction is going from our camera straight to where we clicked. So hopefully this gives you a good understanding of what is happening here when we get our world position and our world direction back. It's essentially taking a point from the camera and casting it down to the ground where the mouse cursor is. And we can use this information to understand how the character is going to face the mouse. So let's do that next. The first thing we'll need to do is understand the distance to ground, and we can create that by taking the ground level, which in this case we'll just do 0 for now, and we subtract that by the world position.z, and then we can divide that by the world direction z, and that will give us the line from the camera to the ground. And this will be a float. And to represent this, we can copy our draw debug line, paste it in here, and we can replace the 1000 here with the distance to ground, and that will show us the exact length from the position of the camera down to the ground. And we'll make that purple, I guess, because there's not a pink. Live compile the code, and let's see what this is looking like. We've got our line here, and blue and purple was not the best color choices, but you can see where the purple begins after the blue, sort of fading in and out there. This might be a little easier to see it. angle it more correctly, but we can see it's coming right down to where the ground is. And that's because this ground is currently at a z of 0, where we use that hard-coded 0 there in the equation. Now that we've visualized our line, we know that world position plus direction times distance to ground is our ground point. So we can create an f vector here to represent our ground location of cursor and set it to that value. And at this point, it would seem that what we're doing here doesn't necessarily reflect what we named our member function is currently getAimDirection, and it would make a lot more sense to follow what dProjectMousePosition to world here is doing for us. So we're already returning a bool, but I think we can rename this and use the same pass-in references, then set that data the same way dProjectMousePosition to world is doing. So let's name this getWorldCursorPosition. Then let's update this in our header file to be the same name. And it looks like everything is getting a little wacky here, so I think it would be good to go to Project and rescan solution again to see if this fixes all of our issues. And it does. Now let's match the out setting of variables that dProjectMousePosition to world does for us. And we'll pass in an f vector, and we'll use a reference to this to set that for whatever is calling this function. And we can call it cursor. You know, I actually don't like getWorldCursorPosition either, so I think we can change world to ground. So we're not really getting the world cursor position, we're getting the cursor ground position. I think that makes a lot more sense for us. So let's update our method here, and then we can add the f vector reference as one of our parameters. Now, instead of setting ground location of cursor, we can just set cursor ground position to our result here, and that will just be set for whoever calls this member function. And we can remove all these debug lines now that we don't really need these. And instead we can take our draw debug point, and where we were once calling getAimDirection, we can paste that in to validate it here, just to see that we're getting the correct thing back. So let's change it to our new member function name, getCursorGroundPosition, and we'll need to make an f vector container to hold the information that the member function will give back to us. So we can pass in cursorGroundPosition, that will be filled by the member function call, and we can replace world position with cursorGroundPosition. And for fun, I'm just going to change the yellow to purple. And now we should see this point showing up on the ground wherever we click, right where our mouse cursor clicked on the ground. And check that out. We're getting points showing up right on the ground wherever we click, so now we know where our player is clicking anywhere on the map. And we can use this information for so much. Now let's get the character rotating toward the mouse position. We can subtract the cursor ground position from the player location to know the direction toward the mouse cursor. And this will be an f vector, and we'll call it direction to cursor. Then to get the rotation of that vector, we can simply do direction to cursor dot rotation. Then we can pass that in as a value to set actor rotation. So let's go back into Unreal and live compile our changes and give this a shot and see what happens. So we can see that the character is rotating a little bit, but not really in the way that we would expect. And just to go a little bit further here, you can see how the character is rotating. If we head into our BP simple character, and using the BP simple character details, we can search for use controller. And we can see here that use controller rotation yaw is checked. So if we uncheck that, compile, and try this again, let's see how it works differently. And now we can see that our character is rotating in the way that we would expect. Only now the camera is also rotating with the character as well, which we do not want. And there's also still the issue of our character's pitch rotating as well. So let's fix all that real quick. First we'll fix our character rotating toward the ground when the mouse is very close to the character. The issue is that our direction to cursor has a Z value, which is giving it a downward angle. So if we set the direction.z to 0, the direction will have no up and down value, and it will keep the character facing forward. And there we go. Our character remains upright whenever we're clicking very close to their feet, and they are always looking straight ahead and rotating with the mouse position. So now let's fix the camera rotating with the character. And along the way, we'll add some other nice quality of life changes here. The Use Controller Rotation Yaw is a property on the Pawn class that the simple character derives from. We can set its value here in the constructor and gain a few more advantages from this. Back in the editor, we can live compile our changes and see what this did for us. Let's head back into the simple character blueprint, and we'll need to recompile our blueprint since we have new code changes. And now we see Use Controller Rotation Yaw has a default value matching what we set in its constructor, so we can hit that and revert it back to false. Setting values in the constructor like this help us understand what it's intended to be, and allows us to make changes freely and always be able to revert back to the default value. So let's do this with a few other properties. We know we've modified the rotation and the target arm length of our spring arm component. So back in our constructor, with our spring arm component, we can do something similar. We can look for the target arm length and set that to our 1400 value. Then for the rotation, we can set the spring arm's world rotation. We can pass in an F rotator where we set the pitch to -60, matching our current setting in the blueprint. Live compile the changes and take a look at our blueprint now. So you can see currently we have rotation default value arrow and target arm length default arrow. So if we compile our latest changes into this, we can see that the arrow goes away for our target arm length, and we just needed to refresh the rotation. So now these are the default values for this component. Now we can tweak these settings a little bit, say we want to try a higher camera angle, a little bit closer to the character. We can compile that, try it out in game, and be like, this doesn't work. I'm going to change it back. Bloop, bloop, back to where we were. No harm done. And I guess we can finally fix those camera settings now. So in the spring arm settings, you can see that there are camera settings for inheriting the pitch, yaw, and roll. And we want the camera to maintain its angle at all times. So let's set these in the constructor so those are our new defaults. We know what the names are in the component, so let's see if we can find them by matching those names. We know they're booleans, so let's start with a B and then inherit pitch. There it is. Set it to false. We can copy paste that a few times, change pitch to yaw on the second one, and change pitch to roll on the third one. Back in the editor, we can go to the main window, live compile our changes, and head back into our blueprint to see how it's looking. Recompile, and now we can see we have defaults for all of these. We're going to turn them off, compile the blueprint, save it, and let's check this out. There we go. The camera no longer moves with the rotation of the character. Now let's make it so our character faces the way they're moving. We could use get movement component for this, but we would have to cast it into a character movement component, and that would just be a little bit more extra work. And either way, we would still need to include the U character movement component, so let's go on and do that. Then, instead of get movement component, we can use get character movement. Now we'll have access to the property B orient rotation to movement, and we can just set that to true. Then with another live compile, we can check out our blueprint, compile it, and do a search for orient in the character movement component. And we can see the default value now represents a true value, so we can reset that and compile, and check this out in game. Now our character is rotating toward the way which we move, and also facing where we click. And together, we can be a helicopter. Since the T-pose isn't the most interesting thing to look at, we can go into the character's mesh component and look for the animation mode. We can set this to use animation asset and change this to one of the available assets we have. There's an idle, which looks fine, but probably not great for what we're doing. And then there's the forward walk, which would probably do pretty well for what we're looking for. Let's try it out. Now this looks a little better, and there's no real animation logic happening here, but I feel like this makes it look a little better while we're testing. So now that we've made some pretty good progress, let's clean up some of the stuff we've done. In our get cursor ground position, we're always returning false, so let's change this to true when we have a success. Then let's mirror the logic of the deproject mouse position to world and use its return value to know when it fails and pass it up the chain. Then we're dividing by world direction.z on line 21. We probably want to make sure that this isn't 0 for any reason before doing this. Even though it's unlikely that it would be with a top-down camera view, it would just be safe practice in case everyone changes the camera values at a point. To do this, we can use the fmath library. We can do if fmath is nearly 0 and pass in our world direction.z. And if our world direction.z is nearly 0, we can just return false. So now we have character running around, we have the data, where the player is clicking, and this is the foundation we need to move forward and do so much more. So in the next video, we're going to be using this data and wiring up through the start shoot, the handle shoot, and the complete shoot, and having it impact different parts of the way the character is acting. Once we've got everything wired up and working nicely, we can start working on the guns and having them fire, and things will get a lot more exciting from there. Again, I don't totally know the direction that I'm taking this. I'm kind of just doing it for fun, putting it out there. If you have anything that you would like to see, anything specifically done, let me know in the comments below, and I'll work towards making that a part of the videos in the future. Until then, like, comment, and subscribe, and ring the bell so you don't miss the next video, leading up to where we'll be implementing the actually fun parts of the game. I'll see you in the next one. Nos queda nisso.